Welcome to Interface Studies. My name is Saleh. Today we're going to discuss an interesting phenomenon in vibe coding. Large language models and vibe coding more broadly have flipped software development on its head. For years, the bottleneck was human speed. Machine idled, waiting for keystrokes. Now, the right phase is moving from the developer's hands into a probabilistic black box. Increasingly, the developer's job is shifting from authoring or typing line by line, even with some assistance, to orchestrating, guiding, testing, and framing intent, or prompting. But this shift brings a new kind of lag. Not a wait for the team to ship thousands of lines, but a quiet delay during development of a few minutes here and several minutes there. We can call it wait window. Too short to leave your desk, too long to stay in flow. In this gap, developers and vibe coders wait. Some stare at the spinner or simply multitask, delegating other tasks to other agents. Developers tap over to Reddit, a video, or maybe a few TikToks. Then a new IDE did something different. It's probably one of the sharpest and most cynical examples of the responses to this trend. CHAD, the brainrot IDE. A Y Combinator-backed project, and its premise is almost nihilistic. While the AI is generating code, the developer is dead weight. Instead of letting you wander, it pipes distraction straight into the editor. When the generation starts, the editor splits. A pane slides open. Not docs, but brainrot. Short-form high dopamine clips or little gambling games. The moment it finishes, the pane snaps shut, yanking your attention back to the code. Promoted as a way to avoid being bored while vibe coding, it actually endorses a fragmented model of work born out of a shift to code generation. A shift coming with LLMs and definitely has a price. Now, beyond the likely cynical play of CHAD IDE, as their YC video hinting at serving ads during generation, there is a real point here. The wait time exists. Now, to see why filling the wait window with distraction is harmful with CHAD or any other distraction really, we have to understand attention. An important point here is attention residue. Researcher Sophie Leroy showed that when you switch from task A to task B, assuming task A is coding while task B is distraction, your attention doesn't jump cleanly. Some of task A sticks in your head. Now, for developers, the reverse is worse. When the AI finishes and the brainrot pane snaps shut, you're looking at the code diff. Task A, while your brain is still riding the dopamine from the video. Task B. Deep work, or System 2 thinking, the slow analytical mode, takes a hit. Studies suggest that it can take up to 23 minutes to fully regain deep focus after a context switch. Over time, this leads to cognitive drift, a gradual resetting of the human's baseline for evaluation due to over-reliance on automation. In Cycle 1, the developer scrutinizes the AI code. But in Cycle 50, with distraction, the developer wants the wait to be over and return to the dopamine source, whatever it is. This triggers a stack collapse. In traditional coding, you keep a live mental stack of variables, control flow, edge cases in working memory. When the right phase moves to an AI, you shift into reading. If the wait is filled with high stimulus distraction, the stack drops. You return and have to cold boot your mental model, which often leads to shallow reviews. Now, large language models and code generation is here to stay, and the goal isn't to erase wait time. But reasoning models will think more, and the latency will grow. The goal is to find a way to turn this wait window from a distraction trap into a design intermission. And I think with it, there will be a change, in habits, probably user interfaces, and processes. Here are some explorations I went through attempting to understand this wait time distraction problem. Let's talk about intent journaling. In intent journaling, we're almost reviving hammock-driven development, which in simple terms means stepping away to think, but slightly updated for the AI era. Before prompting, we can keep a running log of intent, not implementation. We can also do a pre-mortem. While waiting, we write likely failure points. When code arrives, we're no longer passive readers because we used that time productively. We're grading against our understanding and expectations, engaging analytical thinking immediately. And from that, we move into the wait window. The solution here is probably active wait. Current IDEs, even AI ones, display a passive spinner, sometimes reasoning steps, signaling the need to wait. Others, like Kiro and Google's anti-gravity, might provide a plan before the generation starts, which is good. But what would be helpful here is finding a way for that interface to engage the developer in active wait. The first idea is the engagement queue, a dedicated pane that unlocks only while the AI is generating. It prompts the user to write unit tests or any kind of engagement while the code is being generated. Defining success criteria during this wait time will help us remain mentally synchronized with the problem logic, because we're engaged with it. Another approach is the diff narrative mode. Instead of raw text stream, a secondary, probably smaller AI model summarizes the architectural impact in real time. This forces the developer to acknowledge the scope of the change, or the architecture, before getting lost in the syntax, the implementation. Now, these were just some ideas or explorations trying to understand this new phenomenon. There's quite a lot of research required to understand it better and take measurable action against it. And as models are getting better, modern reasoning models and agents can take even more than a few minutes to generate code. They can reach up to 20 or 30 minutes and even more. This means that filling the wait time with distractions is even more appealing and probably more damaging. For example, it will be extremely difficult to verify the massive artifacts returned by the model. The wait window will probably become the primary work time. Code production will become the background task. And for the benefits that come with that, there will be opportunistic solutions, rapidly increased complexity, and a need to change.